Here we have a water tank that's in the shape of a cylinder. It is filled with water, and we given that the tank, the cylinder has a radius of 10, and that water is being drained out of the tank at a rate of 2 cubic feet per second. And so as the water is being drained out of the tank, the height of the water is be from the base up to this level right here. So right now the height is about 9.5 feet. And so as water is being drained out, the height of the water will also decreases. And so what we like to know is if water is coming out of the tank at a rate of 2 cubic feet per second, what is the rate of change of the height of the water? We know it's going to come down, but how fast is it changing? How fast is the height of the water? Again, the height of the water is just the base of the cylinder up to this level right here, up to the water. So that's what we're looking for. And so the formula of a cylinder, the volume of a cylinder is pi r squared h, where r is the radius, so the radius from here to here. And then the height is, in this case, we want to know the height of the water. And so the height of the water would be the distance from here to here. And so to get the rate of change of the height, let's go ahead and add water here so we know that this is the height of the water and not the height of the cylinder. The height of the cylinder is 15, and it's fixed at 15. But the height of the water is changing as water is coming out. And so the height of the cylinder is fixed, it's not changing, but the height of the water is changing as water is being drained out. And so we like to know what is the rate of change of the height. And so we have this formula right here. And this is the same as 1v, and we're given that the radius, so the radius of the cylinder or the radius of the water is the same. And so this is 10, so let's look at it again. So the radius of the cylinder is 10, and so the radius for the water is also from here to here, which is 10. And so we get 100 pi, and then times the height of the water. And then the volume of the water, which is coming out of the tank at a rate of 2 cubic feet per second, is changing. The volume of the water is changing with respect to time. The height of the water also changes with respect to time. And so we will do, so we need to do implicit differentiation with respect to time. And so right here we have 1v, and so the derivative be 1, and the variable here is v, so derivative 1v is just 1. And since the variable here is v, and we're doing derivative with respect to time, then we need to use the chain rule, which means we have to do multiply by dv and dt. And this is the constant 100 pi and then this is the derivative of h. This is h, and we're doing derivative with respect to time, and so it will be times the derivative of h, water or height of water, and with respect to time. And so this is the rate of change of the height of the water. Now we're given that the volume of the water is being drained at a rate of 2 feet per second. So this is dV dt right here. And so dV as the rate of change of the volume of the water is 2 cubic feet per second. And so right here, this would be 2. dV dt is 2, and 1 times 2 is 2, is equal to 100 times this. And then divide both sides by 100 pi. And so we get the rate of change of the height of the water. It'd be 2 divided by 100 pi. And on the calculator, if we divide it, we get 0.006366. And the height, the unit would be foot per second. So this is how the rate of change of the height of the water. So this is rate of change of height of water. So this is how fast the height of the water is changing.